All right, CNT140 patch panel lab. We're going to do a little bit of meter testing on different patch panel connections. So what I have is I have a larger patch panel with a couple of ports on here terminated to a couple of outlets. So I want to test, or I want to show you meter results with our little continuity meter on a couple different cable runs. In addition, I also want to introduce you to and show you our wire mapping meter. Now, your toolkit has the continuity meter. That is the common one that we use all the time. Our lab room has two of these wire mapping meters, but even at that, there's only two. We share them around. But this is able to show us a wire map of our cable run to let us know if everything is wired straight through as I would like in a very visual format. So I'm going to hook up our continuity meter to some cable runs, and then I'm going to hook up the wire map meter to some cable runs and show you what the results look like. Okay, so let me set my patch panel off to the side so we can focus on our meter here, if you will. Actually, I need to move the patch panel over here. There we go. Let's get organized. There we go. And there's our meter. Okay, so I'm going to connect to our first port here. I'm going to connect one end of my meter to the outlet. I'm going to connect the other end of my meter to our patch panel port. So like so. And I will test, and this should be my good cable run. And that's what yours should look like after you terminate. Nice straight through cable run, no issues. Now, I'm going to take and disconnect our meter, our continuity meter from the patch panel. And I'm going to connect our wire mapping meter to the same cable run. Okay, so I'm going to bring my wire mapping meter over here. I need to use the remote end. It looks like an antenna, but it's actually a remote end. That I'm going to plug into my patch panel port. What that does is loop the signal back to the meter. I'm then going to take my little patch cable, plug it into the meter. I'm going to plug that into my outlet port, and I'm going to run here. Hopefully you can see it. There's an option here for cable run. I'm going to run this, and it's going to send a signal down the wire to the patch panel port. The antenna is going to loop it back to here, and I actually see that little wire mapper. I shouldn't say antenna. I think I did say that. The little wire mapper tool here. It shows it going down to that, looping the signal back and coming back. Tells me it's about an 8-foot cable run, and all the wires are straight through. That is a perfectly good cable run. Pin 1 here connected to 1, 2 to 2, 3 to 3, so forth, up to 7 to 7, 8 to 8. Wired straight through. That's exactly what I should see. That is a good cable run with no faults, no issues. That is a very visual way to see our cable run and also get a distance on. Okay? Very useful, very helpful. All right. Now, let's move on to a couple cable runs that have some issues. So let's move on to this guy here. I'm going to hook up our next cable run that actually does have an issue in. As we do this guy, here he is here. Plug my meter into there. Plug the remote in over here. I'm going to run a test on this. And this I see 4, 5 is not showing lit. So if I do the fault check, it'll go through and show 1, 2 is good. 3, 6 is good. It'll probably show 4, 5 blinking, indicating that's open, and 7, 8 is good. So that tells me there's an open on 4, 5. So I would start looking at my white, blue wires on the patch panel end and maybe the outlet end to see what might be the issue. It could be an easy fix on the patch panel. All right, now let's hook up the wire mapping meter and see if that shows us a little bit more visual what I just figured out with the little continuity meter. So let's plug in our port here into the meter, wire mapping meter, and I'm just going to do a refresh, if you will, so it'll run a new cable test. It should pick up my remote end over here. It does. And if I look down there, I'll see that the blue wire is open And if I look closely, 7.8 feet, it's actually going to be at the remote end. It's going to be at this end of my cable run. So it is on the patch panel. So in this case, I would check the patch panel to find that blue wire and maybe re-terminate that patch panel in. So there would be a wire break. There would be a wire break. Okay, so let's move on to our next cable run. I have another one wired up for you. So let's go this guy right here, and we'll hook on our meter on this guy, little continuity meter on this guy, and I will hook on our meter on here. Here we go. So this one will test, and this one shows 4.5 is showing reverse. So on this one, the 4.5 or my blue wires, blue and white blue wire, looks like they got flip-flopped on the patch panel. Well, I'll do the fault check on this guy, or a debug, and go through 1.2 is good, 3.6 is good, 4.5 will probably show an issue, and it does, it shows a reversal, so I know that the white, blue, and blue wire got flip-flopped, and 7.8 showed that it's good. All right, so that's showing me, in this case, the white, blue, and blue wire got flip-flopped on termination. So let's hook up our wire mapping meter to this cable line. I'm going to put the remote end into 6, and I'm going to hook my meter up here into my patch panel port. And we'll do a little refresh on this guy so it does a new cable scan. We're going to look for the remote end again. There is the remote end, and it shows that white, blue, blue wire pair flip-flopped. So indeed, I have a reversed pair is what it's called on most likely the patch panel side. That's what it seemed like on the other meter. That's what it seems like on this end as well. So I would check that patch panel and see if I accidentally reversed those two wires. All right, I have one more out here. So let's move our cable meter over there, over here. I'll plug the remote end over there. I'll plug my meter in over here this time. And I'll run this test. And what do we get? Oh, I see 4.5 and 7 and 8 are showing miswire. So let's do the fault check. I'll hold it down. It'll show again 1.2 is good. 3.6 is miswire. 1.2 is miswire. 4.5 is good. 7.8 is good. So going through again, 1.2 is miswired with 3.6. 3.6 is miswired with 1.2. So what that's actually telling me is the orange pair and the green pair have flip-flopped with each other. They've crossed. Most likely what the issue is, one end of my cable run, either the outlet or the patch panel, I followed the wrong color code. One end I did A, the other one I did B. That's what would cause that cross pair is what it's called. Well, let's see what the other meter shows to see if that kind of confirms what we're thinking here. So I'm going to remove the remote end from here. I'll plug my remote end of my wire mapping meter in there. I will plug my wire mapping meter here. I will do a refresh so it does another new cable scan. I'm going to look for the remote end up there. And it has picked up the remote end. And if I look carefully, the orange wire pair is down in the green spot, and the green wire pair is up in the orange spot. Those two have crisscrossed. That's what's called a crossed pair. And most likely what has caused it is one end got wired to the A color code, the other end I accidentally read the wrong color code and did the B color code, or vice versa. One end A, the other one B. That's what would most likely cause that. So I would look at my both terminations and see if I could find the end that's miswired and fix that end. So there is looking at our patch panel termination after we've done the patch panel on the outlet with the continuity meter that we're used to, and also looking at our wire map meter results to see what some of this looks like after I have our cable run connected, if you will.